This is recording 1C in our series on the quadratic formula for Unit 4, Chapter 4 of Mathematics 2200. We'll be defining what we mean by a discriminant of a quadratic equation, and we'll be determining the nature of the roots for a quadratic equation, as well as the number of x-intercepts for the corresponding function by examining the discriminant. Quadratic formula is applied to a quadratic equation in this form: ax squared plus bx plus c equals 0. Here's the quadratic formula. The discriminant is the part that occurs under the square root sign, the b squared minus 4ac. So d equals b squared minus 4ac is the discriminant portion of the quadratic formula. I've got here three quadratic equations. I'd like for you to pay attention to this one first. Negative 2x squared plus 3x plus 8 equals 0. I've begun to solve it by using the quadratic formula. Negative 3 plus or minus the square root of 3 squared minus 4 times negative 2 times 8 all over 2 times negative 2. And when I calculate the portion that's under the root sign, I'd have 9. And negative 4 times negative 2 is 8 times 8 is 64. So 9 and 64 would make 73 under here. Now, because that 73 is positive, I will have two different cases. So our discriminant is 73. That's the part that occurred under the root sign. It is positive. Because it is positive, the plus case will be different than the minus case. So we'd have negative 3 plus root 73 is a different value than negative 3 minus root 73. So we will get two different roots. Two different real roots, actually, which is what we've said down here, because the discriminant is positive. So I've marked that down right here. Because the discriminant is positive, we get two different real roots. Now, if you recall as well, the roots of a quadratic equation are the same values as the x-intercepts of the corresponding function. So if our equation has two different real roots, then we must have two different x-intercepts on the corresponding function. For our next example, we've got x squared minus 12x plus 36 equals 0. You might recognize that one as a perfect square trinomial. However, here's what happens with perfect square trinomials. You will get a discriminant of 0. And when we do the I've done all the calculations here, but the important point to pay attention to here is that we get a 0 discriminant. So if we were to break that up into our two cases, we would have 12 plus 0 over 2 and 12 minus 0 over 2. Well, adding 0 and subtracting 0 makes no difference. So we have a case where our discriminant is 0, and if we graph the corresponding function, we will get one x-intercept, because we really only get the same root twice, 12 over 2, which is 6 in this case. That's the only root we would get. So we get one x-intercept, which we call two equal real roots, because the plus case and the minus case are one and the same. They are equal to each other. Meanwhile, over to this one, 3x squared minus 5x plus 9. I've already solved it by using the quadratic formula. But here, I've got the square root of negative 83. Now, the square root of negative 83 is not possible to do using the real numbers. So that gives us non-real roots, simply because we get a negative number under the root sign. We can't do the square root of a negative number using real numbers. So we will have non-real roots. Therefore, we have a negative discriminant. I should have said d equals 0 down there just to be consistent. We have a negative discriminant, and therefore we have no real roots. And since there are no roots, there cannot be any x-intercepts when we graph the function. In conclusion, the discriminant of a quadratic equation is d equals b squared minus 4ac. The three cases of the discriminant are: if the d value is positive, the quadratic equation has two unequal real roots because that number under the root sign would be positive and give us two different cases, the plus case and the minus case in the quadratic formula. If d equals 0, we'll have one real root because in the quadratic formula we would have plus the square root of 0 and a minus the square root of 0, which is not going to make any difference. And if the discriminant is negative, we would be trying to take the square root of a negative number in the quadratic formula, and therefore there cannot be any real roots. And the corresponding function would have no x-intercepts.